Right, so looking at this calculator, looks like there's a problem with this switch. We bring the meter in here. Hopefully I get the meter in here. If we touch these two together, it should beep, which you can see it does. If we connect these leads to the switch and we turn the switch on and off, it should beep when it's on. Like if we sit there and play with it a little bit, looks like we've got it to work a little bit. We'll see it's not working now. So we definitely need to take this switch apart and see what's wrong. So I'm going to disconnect the meter. I'll set the meter aside here. And I'll disconnect it from the leads. And then let's see here. Get a pair of pliers. Alright, and we will carefully bend these tabs, which should allow us to open up this switch. This is a very old device from, I believe, the 1970s, if not earlier. So we want to be very careful that we don't break any of these plastic pieces. Let's see here. Okay. I need to bend that one a little more. And then there we go. Now this thing switches the full 120 volts to this through this switch. So if you can see in there or not, let's dump the contacts out and take a look. I don't know if you can see in there. Let's see if I can zoom in a little bit. Get some light. There seems to be a lot of gunk in there. So let's see if we can clean that up. Get that to work every time. Definitely got some green fuzzies in there. So I'm going to get some canned air. See if I can blow some of that stuff out. Definitely a little bit of corrosion in there. Get some, see what these contacts look like. See if we can focus on those or not. They're a little dirty. But I think the, whoops. And I dumped all the pins out. So let's put that back together. A spring there, a pin there, and a pin there. So what this mechanism does, these two little plastic pins, it's a pivot. It pivots on this little rocker arm here. And that way it does a snap when it makes a connection instead of a slow connection or a slow, because it would arc, the switch would arc if this connection wasn't quick and solid, because we're switching the full house current, you know, the wall current. So you have to be careful about arcing. That's why in those previous videos, some of that arcing on the contact relay contacts, you want to prevent that from happening on this switch. So I don't know, it looks pretty clean. Looks like you may be able to see some arcing that may have occurred in there. Let's see if I can get a light in here. Kind of see some pitting in there. So I'm going to see if I can clean up those contacts with a, just going to take a screwdriver here and see if I can kind of scrape them a little bit, get them clean. It would be hard for me to get a file in there. Just gonna get in there and see if I can clean those up a little bit. And we'll put the rockers back in, like so. See, got the rockers in there. Then I'll put the top of the switch back on. Let's see. Oops, get those all. Yeah, this is going to be kind of tricky. Get those pins bent out better. Let's see here. Get those rockers back in there. One just hit the floor. Okay, got that rocker back. Let's drop it in there. Let's see if I can get this now. Looks like when you snap that way, it's on. So that means I want to get the rockers this way. Okay, so let's see if that works. I'm just going to squeeze that together. Candle out of the way. Going to connect this guy here. Test it. Yep, I still got a good beat. Looks like it's working and it's in the on position. If I switch it to the off position, it goes off. On it goes on. So it looks like that switch is all cleaned up now. So what I'll do is I'll now bend these leads over here, or these tabs, so that switch will stay together. So give that, oops, give that a little bend there. Bend one tab on the other side here. It's probably a special tool or machine they use for that. Okay. And just for fun, so I bent one tab, but not the other. I'm just going to test it again to make sure it's still working, make sure I didn't get anything out of alignment. So it's in the off position. If I turn it on, the meter should beep, and it does. So it looks like I'm getting a good contact now. So I'll go ahead and bend the other two tabs to keep that switch closed and in position there. And let's see here. All right. Looks Looks like it's still working. Once again, let's give it one more try. Better to test it 5 times than have it fail when you get it all back together. Currently it's in the off position. On, off, on, off. So that looks good. So now I'm going to, you can see here, it is pretty dirty. Got quite a few dust bunnies in there and just generally filthy. So I'm going to go ahead and clean it up, and I'm going to put it back together, and hopefully that'll fix it. So this is interesting. It may be kind of hard to see, but this is one of the keys. And if you look, that little glass tube that you see right there, that has 2 pieces of metal in it. And that the key is hooked to that little moving piece right there. There's a magnet on there. And when you press the key, it pulls those 2 pieces of metal together in that glass tube. And that's what registers as a key press. It's just what's called a reed switch. And you could take a regular magnet like this on the tip of a screwdriver. And if I hold it near there, you see it activates the key as well as if I press the key. Anyway, all the switches on this keyboard are like that. All the buttons on this keyboard have little glass reed switches. That's a very old way of making a keyboard. Very expensive way too, because each one of those little reed switches had to be soldered in there. One for every button. See how they all work there. When the buttons get pressed, the magnets come up, activate the switch. Alright, so here it is, almost all put back together. And I've got some power hooked up to it right now. Actually, I'm gonna turn on the power here, and just to give it a quick test, I haven't put the top cover back on. I've got some jumper leads going to the power right now, and we'll go ahead and give it a try. And there you go. As you can see, it seems to be working. 123 plus 321 equals 444. And let's see if we can look over here at the power meter. And let's see. I don't know if you can read that or not. See if I can rotate that. There we go. You can see it's drawing about 12 watts of power, which is quite a bit for a 4-function calculator or an any machine. It's drawing about 100 to 110 milliamps of current. So quite a power-hungry device for a simple calculator. So I will finish putting it back together now and make sure it still works. So, as you can see from the bottom there, this is a Commodore C112 model of calculator. And it was serviced at Calculator Service International, maybe, in Santa Clara, California at some point in its life. I believe this is from the 1970s. And there is a view of the top cover there. You can see it's a Commodore C112. And let's power it up and see if it works still. Got all the covers back on. I will connect these jumper leads. This is 120 volts. You can see by the plug there, so need to be careful, make sure nothing gets shorted out. much that will work. I don't have the original power cord. Alright, get that lined up there. Maybe zoom in a little bit. I'll apply power to that cord. Then press the power button. And there you go. Looks like it's working. So, I don't know what that does. That's the con button. It locks down, but 123 plus 321 equals 444. Divided by 2 equals, wow, 222,000. That's funny how it shifted all the way up there. Again, I don't know exactly how to use this. There may be some old tricks or old reasons for it acting the way it does. 3 times 3, 9 times 81 times. Let's see if we can get it. Yep. If you see that little red light there, it says overflow. So that means we went higher than it can calculate. So we hit clear. And there you go. There's the 1970s Commodore calculator. Probably while they were making computers, or maybe even before.